Hi everyone, today we are again back with another interesting problem called superdigit. So this problem is about finding a superdigit from a given series of digits or string of digits you can say. So for example, if this 9875 is a string of digits that you have got, so the idea is to sum them or add all these digits, and if the sum turns out to be more than one digit number, then once again that number should be once again subjected to the function or the super digit, and we keep adding it till we get a single digit. So like in this case, we got in the first time we got some 29, and then when we add 2 plus 9, 2 and 9, and we get 11, once again two digit number. And this two digit number, once again when we add the digits of this number, we get a single digit number, and that's what our answer is. To implement this function, we have used this Java code which is using a bit of recursion, with an interesting catch here that apart from the string we are also given integer k, which is a multiplier, which is kind of number of times that string gets repeated, just to make it a slightly more complex. So as you can see in this, we are using this 9875 as our input string, along with k is equal to 4, the multiplier equals to 4, just to elaborate how this code works. So if you look at this string n for 9875, it's actually going to be not stored as a number, but all these characters 9, 8, 7 and 5, they are stored in four different I would say bytes, if it is byte characters. And this is having the decimal representation of 9 is having 57, 8 is having 56, and 7 is having 55, and 5 is having 53. So if you look at our code, we want to now sum 9, 8, 7, 5, not 57, 56, 55 and 53. So we need to get the value 9 from 57, and 8 from 56, and so on and so forth. So if you look at our code, our code is n dot char at I minus character 0. So character 0 is having a decimal representation of 48. So the moment we start processing the first character, and as our loop starts from in the code, you can see our loop starts from the last character and we move from last to the first one. So let's start processing the character 5. So it would become character 5 minus character 0, which is 53 minus 48, value 5, and the sum becomes 5. Similarly, when we process it for character 7, the sum becomes 12. Similarly, for character 8, the sum becomes 20, and for character 9, sum becomes 29. Now, if you look at the code, because we have to do the 4 times of repeat in this example, so sum actually becomes sum into sum multiplied by k. So 29 into 4 is equal to 116. Once again, because super digit is a function where we are talking about if the number is more than one digit, then we should subject it to the function again. So that's what we have represented in the code. If sum is greater than 9, then we are calling the function again with the sum that we have received. Otherwise, we are simply returning the sum. So now we'll once again process it for 116. So 116 is having this representation, and having this each character is having this decimal representation: 149, 149 and 6, 54. Once again, when we have our code executed where 0 represents 48, so first one is we start from the last, which is 6, character 6 minus character 0, our sum becomes 6. For character 1, once again will become 7, the sum once again for the last one, the sum becomes 8. Now if you look at the code, it says if the sum is greater than, then only you need to execute the function again, otherwise you just need to return the sum typecasted as an integer. So that's where the sum turns out to be 8. So this is the result of the function, and it is perfectly all right, and it works. It's a recursive function with the proper ending conditions. I hope it was clear to you and you enjoyed this explanation. If you want to do really good with the solving problems, you may want to join our community. So this is our website, which is launchpad.infinilearn.org. Get in touch with us and join our community to do really well in this industry. Thank you.